Hello all, welcome to the fourth session of the SAT series. In this episode, we are going to talk about the exponents. What are the different types of questions which come into picture related to exponents and how do we deal with them? Okay, so let's go ahead with this question. So 3 to the power of a plus b is equal to 243 and 243 to the power of a minus b is equal to 3 and we have to find the value of b, right? So in all such exponents related questions, the first thing which we have to think is try getting the same base on both sides of the equation, because when the bases are same then we can equate the powers and so on and so forth. Let's see what I mean by saying that, right? So if we look at this first equation, the base here on the left side is 3. So we need to think whether we can write 243 in terms of base of 3, and when we think that yes we can, right? 243 is essentially 3 to the power of 5, correct? So the first equation becomes 3 to the power of a plus b is equal to 3 to the power of 5, right? Same thing we can do for the second equation. So instead of 243 we can write 3 to the power of 5. So 3 to the power of 5 and then everything to the power a minus b is equal to 3, or essentially 3 to the power of 1. Now we have made the same basis on both of these equations, correct? So it means that the powers have to be the same. So we get a plus b is equal to 5, and here the powers get multiplied. So the power here on the left side would become essentially 5a minus 5b, because you will multiply 5 with a minus b. So this actually becomes 3 to the power of 5a minus 5b, right? So 5a minus 5b is equal to 1. So 5a minus 5b is equal to 1, right? Now we have got this system of equations which we can solve together to find either a or b. In this case we have to find b, so we should think about eliminating a, right? So we can multiply this first equation by minus 5 on both sides. So when we do that, we get minus 5a minus 5b is equal to minus 5 times 5 is minus 25, right? This is our equation 1, this is our equation 2. We add both of them to get 5a and minus 5a get cancelled out. So we eliminated a, which is what we wanted. Minus 5b is minus 10b is equal to minus 25 plus 1 is minus 24. And then you divide by minus 10 on both sides to get the value of b, which is equal to 24 over 10 or 12 over 5. Right? So just to quickly reiterate, in all these exponents related questions, what we will be doing essentially is to try to get the same base on both sides. When the bases are same, then we can equate the powers, essentially getting two equations which we can solve like system of equations. Let's take another question quickly. So 8 to the power of 4 over 3 times 8 to the power of minus 8 over 3 is equal to 1 over 2 to the power of m, and we have to find the value of m, right? So the first thing is that when the bases are same and when we are multiplying two terms with the same basis, the powers get added, right? So it will be 8 to the power of 4 over 3 plus of minus is basically minus 8 over 3, which is 8 to the power of minus 4 over 3, right? So essentially our left side becomes 8 to the power of minus 4 over 3. Now we see that on the right side we have the base of 2. So we got to write 8 in terms of base of 2, and yes, 8 is 2 to the power of 3. So instead of 8, we can write 2 to the power of 3 to the power of minus 4 over 3. Right? We just written 8 in terms of base of 2. These powers will get multiplied. So we get 2 to the power of minus 4. So 2 to the power of minus 4 is equal to 1 over 2 to the power of m. Correct? Now this is a negative exponent. We can do the reciprocal of this term and make the exponent positive. So it becomes 1 over 2 to the power of 4 is equal to 1 over 2 to the power of m. Right? Our bases are same, our numerators are same, and m is equal to 4. M is equal to 4. Again, just to very quickly reiterate, we added these powers because when we are multiplying the same bases, the powers get added. So we got 8 to the power of minus 4 over 3. Then we wrote 8 in terms of the base of 2, which is 2 to the power of 3. The powers get multiplied, we get 2 to the power of minus 4. It came down, and finally we got m is equal to 4. Okay, let's see another question. So 2 to the power of a plus b, everything to the power of a minus b is equal to 16. P square is given as 5, and we have to find the value of a such that a is less than 0, right? So again, the first thing is that we know that the powers will get multiplied, right? So this essentially becomes 2 to the power of a plus b times a minus b, right? This power, this whole thing will get multiplied with this whole thing, right? Is equal to 16. As we discussed in the previous question, right? We have to think, how can we write 16 in terms of the base of 2, because we see that the left side has the base of 2. 16 is 2 to the power of 4. So instead of 16, we can write 2 to the power of 4. Right? Now we have made the same bases. Since the bases are same, it means these powers have to be equal, right? For these two sides to be equal, if the bases are same, then this whole power has to be equal to 4. So we write a plus b times a minus b is equal to 4. Now this is nothing but the difference of the squares, right? So a plus b times a minus b is essentially a square minus b square is equal to 4. B square is already given as 5. So a square is equal to, you bring b square to this side, 4 plus b square, plug in the value of b square, which is given as 5. So 4 plus 5 is equal to 9, right? So essentially we got a square is equal to 9, right? You square root on both sides, and we get a is equal to plus n minus of 3, correct? Now since a is given as less than 0, we will discard the positive value, and our answer would be a is equal to minus 3. Right. Again, as we saw, the trick here is simple. We have to play in such a way that the bases on both sides are same. When the bases are same, then we can equate the powers and take it from there. Hopefully the video was helpful and it gave you a perspective as to how to deal with the exponents. Please do like and subscribe. See you in the next session.